Today, the storage of electrical power has become a priority issue for the energy transition, and more specifically that of storage referred to as stationary. This technology is growing significantly in connection with the development of intermittent renewable energies such as photovoltaics. I will therefore start by presenting the approach through its Zinium startup players in collaboration with the EDF R&D division, who developed the zinc air technology, making it rechargeable, developed an electricity storage battery called Zinium. Like every adventure, nothing was achieved in one day, and the challenges were multiple. However, researchers and engineers were able to make this dream a reality. At the outset, the specifications were not so simple. The initial questions that came up were as follows. Why store? How can we store using zinc air? For whom? And at what price? Accordingly, it may be necessary to store electricity when networks are absent or defective, but also in other situations, for example, when we wish to store production from our renewable energies, even if the network is reliable. Using battery storage, we can store the energy produced during the day for use when required. This enables us to make savings and improve our self-consumption rate. As a result, everyone can become a committed player in the energy transition. Next, it was a question of developing solutions firmly rooted in the future while meeting current needs. Environmental impact, recyclable material, no rare minerals extraction. It is in this sense that the zinc air technology is one of the most relevant at the present time and for the future. It mainly requires zinc, which comes from recycling plants, and oxygen, which is found in the air all over our blue planet. However, before talking about this technology, there's a final important point I would like to share with you, the safety of this technology. It has already been used for more than a century in the form of non-rechargeable batteries, for example, to power hearing aids, since it can provide a small amount of continuous energy without its temperature ever increasing. This makes it a safe technology, suited to use in the vicinity of each person. So now, how exactly does it work? I would actually say that it has to be seen to be believed. The Zinium battery is a bit like an object that breathes, with cycles that are similar to those of animals, except that it breathes in oxygen while delivering electricity and releases oxygen when it recharges. And this happens once a day. It is also managed by an electronic system, which enables it to distribute air in each of the battery's cells in order to optimize its use in line with our requirements. It all seems simple, doesn't it? Today, now that Zinium has developed this technology and determined the various issues related to its marketing, including sizing according to electricity storage needs for a house, a housing community, a commercial or industrial building, a neighborhood, etc. Zinium will soon launch its industrial production, followed by European marketing. In effect, the right to directly consume our energy production and to store our energy surpluses will enable the most balanced energy mix possible between existing networks and local production. This will therefore offer greater flexibility in our consumption and the possibility of developing new innovations for the benefit of our planet. Thus, everyone can become an even more committed player in the energy transition.